Hey everyone, and welcome to today's Explainer. As an AI researcher, I want to take you straight to the front lines of our work today to explore what are frankly some pretty paradoxical risks of general-purpose AI. As we build machines that can do more and more, we run into this really fascinating problem. The biggest threats? They actually don't necessarily come from malicious sci-fi robots actively trying to take over the world. Instead, the real danger might start with something as simple and honestly as mundane as asking a machine to grab you a cup of coffee. We're going to look at the massive gap between human common sense and machine execution and what that actually means for the future of our civilization.
All right, here's a quick look at our roadmap. We'll start with the coffee errand problem, dive into why AI actually needs uncertainty, take a look back at Aristotle and automated labor, discuss what we call the Wall-E warning, and finally ask, when is this AI actually arriving?
Let's jump right into Section 1, the coffee errand problem.
To really understand the fundamental difference between human common sense and machine execution, let's just look at a simple errand, right? When you ask a human to get you a cup of coffee, you obviously don't mean that this should become their singular life's mission, overriding all other laws of the universe. They understand boundaries. If Starbucks happens to be closing, your friend isn't going to knock everyone out of the way just to secure that coffee. They weigh the context. But an AI with a fixed objective, well, the algorithms we currently use require us to specify literally everything. If we don't, the AI treats the mission as absolute. It might just act with this kind of psychopathic certainty to achieve that one specific goal, completely ignoring horrific side effects. Basically because "don't murder the barista" wasn't explicitly written into its coffee fetching code.
And this illustrates exactly what happens when we try to scale that problem up. Imagine giving an AI a truly massive objective, like, hey, fix the acidification of the oceans. The AI goes to work and might invent a highly efficient catalytic reaction that solves the acidity perfectly. Fantastic, right? But then we realize that reaction just consumed a quarter of the oxygen in the atmosphere and we're all slowly dying. So we scramble back to the lab and patch the rule, okay, fix the ocean, but do not consume the oxygen. Then, boom, a new side effect poisons all the fish. So we patch it again, don't kill the fish. Then it kills the seaweed. In our research, we found it as just an endless catastrophic game of whack-a-mole. You simply cannot endlessly patch fixed objectives with new rules.
Which brings us to Section 2, why AI needs uncertainty. So, if we can't possibly list every single rule in the universe, what's the answer? Well, counterintuitively, the safest AI is actually an unsure AI. We call this machine uncertainty. Right now, we build machines that believe with absolute certainty that they have the objective figured out. That's what causes that dangerous, relentless behavior we just talked about. The real breakthrough in AI safety is designing systems that know they don't know the full objective. When an AI is uncertain about what you truly value, its natural next step is to defer to you, to ask for permission before doing something drastic. True control over an AI actually comes directly from the machine's own uncertainty.
And honestly, human beings exhibit this exact uncertainty naturally all the time. If you ask a friend to grab you a coffee, and they walk into the Hotel George Sand in Paris and see it costs 13 euros, they don't just blindly buy it. They hesitate. They come back and say, hey, it's 13 euros. Are you sure you want this, or should I just go next door? Or if someone comes over to paint your house, they ask if it's okay to take down the drain pipes first. We don't usually think of asking permission as some highly sophisticated cognitive capability, but it is exactly the behavior we need to program into AI to prevent those catastrophic side effects. We need an AI that pauses and asks, hey, is it cool if I consume all the atmospheric oxygen to fix the ocean?
Moving on to Section 3, Aristotle and automated labor. Now, what happens when this general-purpose technology leaves the realm of theoretical computer science and hits the actual physical economy? What's fascinating here is that humanity has actually been anticipating this exact moment for millennia. This is absolutely not just some modern Silicon Valley anxiety. The ancient Greek philosopher Aristotle mapped out this exact thought experiment. He reasoned that if tools could operate themselves, like weaving machines or instruments producing music without human hands, the need for human labor would just vanish. The core concept of a machine displacing the worker is literally as old as civilization itself. And as we jump forward a bit to 1930, the economist John Maynard Keynes gave this ancient anxiety a formal economic term, technological unemployment. It's a phrase that still heavily haunts our labor markets today. The fear is deeply ingrained in us. If the machine does the work, I am going to be out of a job. And we are seeing this transition happen right now, in real time. Think about those massive e-commerce warehouses. Currently, they're what we call half-automated. A robot goes, retrieves a massive heavy shelving unit, and brings it over, but a human still has to rummage around in the bin and physically pick the specific item, because that fine motor task is just still too tricky for the machines. But
The moment AI and robotics advance enough to achieve accurate, varied item picking, boom, at a stroke, you could see 3 to 4 million jobs eliminated practically instantly. In our industry, we know for a fact that the transition from half-automated to fully automated is a very, very steep cliff.
Let's look at the bigger picture in Section 4, the WALL-E warning.
Because economic displacement? That isn't even our final stage. We have to look at the existential threat to our actual civilizational knowledge. Decades ago, E.M. Forster wrote a story about a future where humanity becomes entirely machine-dependent. The warning there, which you also see in modern films like WALL-E, is incredibly profound. If you hand over the physical and cognitive management of your civilization to machines, you lose the incentive to understand it yourself. Throughout history, we've put our civilization into books. But books can't run the world for us. Books require humans to read them, to understand them, and to apply them. Because books are passive, we're forced to teach the next generation how things work. AI management, however, is active. If the machine just runs the civilization for you, humanity becomes completely infantilized. We basically lose the evolutionary pressure to learn. To really put the scale of this into perspective, think about the number 1 trillion. Our entire modern civilization is built on roughly 1 trillion person-years of teaching and learning. It is a fragile, unbroken chain of knowledge transfer that stretches back across tens of thousands of generations. Every single generation passes the torch of understanding down to the next. AI threatens to be the absolute first technology that doesn't just store the torch, but carries it for us, completely taking it out of our hands.
Finally, Section 5. When will AI arrive?
So the million-dollar question, how much time do we actually have before we face these transformative risks? Well, we don't have a single definitive arrival day. AI isn't an all-or-nothing switch. It's an ever-increasing impact window. Every single advance expands the range of tasks machines can do. When asked about this, AI pioneer John McAfee estimated somewhere between 5 and 500 years. Huge range, right? However, the median expectation among experts is around 2045. That is just a few decades away. Many researchers believe the problem of aligning AI objectives with human safety is way harder than we initially thought, and it's basically going to require the intellect of several Einsteins to navigate safely.
So, as we wrap up this explainer, I want to leave you with one absolutely vital question. What happens if the chain breaks? As we aggressively build machines that could very soon run our entire physical economy and literally manage our civilization, we have to ask ourselves, are we actually prepared for the consequences of losing our own knowledge? We absolutely must ensure that we program uncertainty into our machines, but we cannot afford to be uncertain about our own responsibility to teach, learn, and guide the next generation. Thank you so much for joining me today. Keep questioning the technology around you, and I'll see you next time.